attending these classes?
They will give.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty, who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared, and if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which is really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother, I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary, that is the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens. And they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required, even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Hello everyone. My name is Tasneem. I'm the senior manager at 98 Percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them. till today, I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT Bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them very all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. It was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Good afternoon, everyone. Hope all are doing good. So, yeah, it's time to start our session. So today we have our trainer Advait. So Advait, you can take up the class. Thank you.
Okay, thank you, Chandana. Good afternoon, all. Hope you are able to hear me. So I'm sharing my screen first. Okay, and I hope you are all able to see me as well. So I think we have discussed what is machine learning yesterday. We are focused on about the machine learning part, specifically which comes under artificial intelligence, of course, obviously. And we are learning about what exactly the linear regression part. So we have taken an example as what, going back, scroll down. Yes, we have taken a project from the business problem, like a lot of customers are getting like now in the banking sector. Yeah, lot of customers are getting calls from the different banking domains. So yes, as like as I told, like what if a bank manager want to execute the operation as like identifying, predicting the right customers and calling them directly instead of making up the calls for irrespective of whatever the background. Yeah. So instead of making all the calls for unnecessary people, let's focus on the people who are ready to take. So this is the task, and I told that, yeah, what are the different kinds of streams will be there inside that project. So big data engineer, data analyst, data scientist. What exactly data analyst will do? Looking at the past data, he'll try to apply some visualized techniques and making us understand in the current scenario what's going on. So that is what data analyst. After that, what's data scientist going to be done? He's going to predict about the future cases, right? So this is what we discussed. Then after that, yes, we taken up an example as yeah, I think I have taken the what is machine learning. What is machine learning? To be frank, we are making our machine trained. That's what we discussed, right? We are making our machine trained by passing some data. I have told some examples like how a kid gets trained on day-to-day times. Here also we are making our machine to be trained when I'm passing some data. Sir, voice is not audible, Chaitra. Give me a minute. Let me check from my end. I think it's look all correct only, Chaitra. Yes, remaining people, can you hear me? Voice, my voice is clear. Can anyone respond? Is my voice is clear or not? Ashok says yes. Okay, good. Chaitra, I suggest just to relog in yourself once again and increase that volume in the laptop. Maybe you could have reduced it for some reasons. Check your volume of the laptop. Maybe it will give better outcomes. Okay. Yes. Thank you all who are responding for me. So what is machine learning? Yeah, we are making our machine trained with respect to supervised learning methods, with respect to unsupervised learning methods. Today, after 1 hour of discussion, I may take the chance of unsupervised learning discussion. Okay. Yesterday, we talking about what? Regression models. So, what's the problem here? Yeah, the problem is what? A company owner received to us and he was worried about the sales. He is investing his money with TV, radio, as well as newspaper in predicting the sales. But what is happening here? He did not able to understand that actually which one is really making more influence on the sales. So we constructed some scatter plots. We noticed that TV, radio is doing well, newspaper is not doing well. But however, we want to make our machine to be trained, and we have executed the Python code for it by calling the dataset inside. And then we made scatter plot, all these plots. That after that, yes, we call the linear regression function and we fitted the model. What that model? A mathematical model, a machine learning model that you are asked to fit the relationship between X and Y. What is Y here? Sales, where we are trying to predict it. And what is your X? TV, radio, newspaper. And we are trying to identify the relationship, how TV is influences sales, how radio influences sales, how newspaper will be influences sales. And we fitted the model and we can start predicting the values with respect to any kind of inputs. So this is what we covered in the last lecture. So there are a lot of some more calculations are there inside the linear equations, but I'm not going to into the deeper learning of those things. So I would like to give another example with another concept for today's lecture. So linear regression will be worked out in what cases when my target variable, which my y variable is sales kind of data, because if it is a continuous random variable, continuous variable means what? If it is following units such as weight of the person, which is kgs, sales of the company, which is rupees, okay, profit of the company, again it is rupees, okay, height of a person, centimeters, distance that you are traveling, kilometers, okay, and let's say how much of premium amount to be will be decided to the customer based on his age. Premium amount for what? Insurance companies are talking. How much of premium amount to be given for you based on your age, based on your work nature, based on your health habits? What amount of premium amount to be given to you? So these are the cases where I can approach linear regression cases. Like there are several cases are. But what happens if my variable is something like, what happens if my, okay, sorry, if my target variable in the form of binary nature. Binary means what? Only two possible outcomes, such as yes or no. Like yes or no. For example, a person visited to the hospital to predict, to identify that. Does the person is having what? Diabetes or not? Okay. Or the person is having cancer or not? Or the person is having COVID or not? Several things are there. Heart attack or not? Or disease there or not? I'm talking about health sector. If I take another sector, let's say e-commerce, a person is going to purchase the product or not? Right or not? Okay. If I take another sector, purchased or not, if I take e-commerce, if I take a telecom domain, will he is going to telecom domain? Will he is going to, will customer, will means what? Will, yeah, customer, okay? Will customer is going to pay the bill or not? Is going to, okay, purchase the recharge card, or pay the post-pay bill or post-bill, okay? Post-paid bill, I mean, okay? The customer is going to pay the bill or not. Like that, if you see, all these are cases are what, like in a binary outcomes, purchased or not, yes or no, true or false, male or female. Okay, so customer is going to pay the bill or not, and a banking sector will get the EMI paid or not paid for the next month. So these are the cases where I can apply what? Logistic regression. The method which will be applied for these kind of cases. Let me take up some more examples in the reality where we can apply the logistic regression. So this logistic regression is coming from where again? From the machine learning concepts only, from the classification models. Look out here, I mentioned as logistic regression. So this will comes under classification models. Let's move forward to understand some more examples. So I have collected some examples. Look out here. Logistic regression is widely used in various industries for the binary outcomes like yes or no, success, failure. Some of the examples such as banking sector, loan default prediction. Predict, we are trying to predict a customer will go to, okay, will pay the loan amount or not. If I by default, if I give a loan approval, will you pay me back or not? I have to verify your credit history. I have to verify your income. I have to verify other financial factors, like do you have any other loans or not. So there are several cases will be there to predict him as a is the person is really going to pay the loan amount on time or not. So here I'm going to take a machine learning model, determine whether transaction is really fraud or based on past patterns in the transaction. So the transaction that we are making, sometimes nowadays now you are getting a lot of junk emails in the Gmails. Sometimes you are getting in the form of SMSs also. Hope you are observed it. So press that link, press this link somewhere there, yeah, some information. So those are like fraudulent transactions. We should not touch up all those things. So our machine can be able to identify that, to ignore that, okay, to ignore that kind of emails, to not send to the user. So that means what, when you are opening your Gmail account, you could see some of the emails are under the inbox, some of the emails are under the spam box. So those are like spam box contains what? All are fraudulent emails, fraud emails, marketing emails, or some other emails. So we should avoid such emails. But before it is reaching to your system, before it is reaching to your system, hope so you are understanding what I meant to say. If you want me to show an example, yeah, I can make sure. So let me show up my Gmail, what it contains. Let's have a look. So if you see, these are the emails generally which I receive from different places, okay? And if you observe that, yeah, there is a spam emails are there. Look out here, spams. If you see, lot of emails are there. Okay, so I don't know what it is. This CX Economia. From where it is received, I don't know. But actually, I did not pick it out to send into the spam. My machine learning is working in the back end of the Gmail. Okay, trying to put those people, put such emails into spam box by default. Before it is received to your email account, machine learning, that means a Gmail that people are using now, Gmail has such a capacity to detect that which emails to be sent to the user's inbox, which emails are sent to the user's spam box. And if you see that there are several emails, sir, I don't know what is mentioned, hi-fi. So a lot of things are there to make those people, making you attract. So what happens here? Yeah, our Gmail is like responding before it is reaching to Gmail itself, responding you and putting those emails into the spam box. I got 70 emails in the spam box. If you go to the inbox, you will have some official emails. But if you go to the spam box, lot of junk emails will be there, which is not ready to, which is not, we are not supposed to accept such things. Hope so you are understanding what I'm talking. So the binary, so our logistic regression is actually working in the backend where it is recognizing the things. This is one of the best examples. Now, financial sectors, yes, a customer is going to purchase or leave the financial services. For example, I'm taking a loan and I want to leave this from so and so bank to some other bank. That's one case. Tours and travels. Predict whether a travel booking will be cancelled based on the customer behavior. I am purchasing a ticket 1 month before, but there is a possibility that I may drop that ticket at the end of the day. So based on your past behavior, so look out here, booking lead time and other variables information. We are trying to estimate that he is going to purchase the ticket or he may go to drop the ticket also. It could be anything, which is under the tools and travels cases. If I take in the e-commerce sector, yes, predict whether a customer, whether to predict a visitor will make purchase the product or not based on your browsing history, based on your cart additions and other online behaviors. So under the e-commerce also, people are making use of this logistic applications. Insurance sectors predict whether an insurance claim will be get approved or denied. So if he is applying for loan claim or claim insurance, will that customers will be gets approved or rejected based on his other customer information. So in the insurance sector also will be applied. Such as, yes, as I told, healthcare. Predict whether patient has a particular diseases based on his symptoms. Like as I told, it could be cancer or diabetes or any other issues which comes under healthcare sectors. Manufacturing sectors, whether a product will be having defects based on the process data. Because when, so for example, the manufacturing industry, sometimes machine will get stuck for some unknown reasons. So at what time interval, again that similar, the similar kind of issues will get happens. Like now, again machine will get stopped after 9 months or after 12 months. So that defects detection also can be applied through logistic regression. Automobiles. So I'm talking about, yeah, whether a customer is going to purchase the particular vehicle based on their demographics. That means what? Which reasons those people are belongs. Based on his preferences. Based on his past interactions with the dealership. How many times he has visited. So there is a possibility that this person is going to purchase the vehicle or not. Like that, we have several cases. So I mentioned about some 7 to 8 examples, but where we can apply the logistic regression, several cases. Hope so everyone is able to understand this scenario which I'm talking here. Can you respond here in the chat box? You are able to follow me. Please respond so that I can understand. So that I can understand that I'm going in the right flow. Please respond in the chat box. You are able to follow me. I see only 3 people, 4 people. Good enough? Okay, fine. Yes. So, because why I'm asking you is to understand that whether I'm in the right direction or not. So, logistic regression is such an important algorithm or machine learning in the industry of any industries, in the machine learning entire such, in the AI world, in fact, in the AI world, which is a traditional method from last 30, 40 years, which has been adopted in the many areas, in the very vastly it has been applied in many areas. Now currently we are having the technology with us, we have the databases with us, we have the highest human resources that people are known about it. So people are making use of these things. Earlier only some people are known, like from the persons of statistical background or computer science background, only people are available. Now we have such a institutes like XLR where lot of people are getting trained and understanding the purposes of this algorithms, machine learnings, and people are making use of in their real world as well. Okay. Now today we are going to work on the data set of the logistic regression. So I'm going to make you show what is the example that we have for this. So this is yesterday's file. I will ignore this one. I'll take up a new file, fresh file for for logistic regression. So I have a data set of breast cancer information. So nowadays, cancer is spreading like anything. Until now, no one have the perfect clarity that for which person is going to have the cancer. Okay, so in the countries such as US, okay, in the IT companies or any other companies, people are often given recommendation to their employees, okay, to do all the medical tests, for each and every employee within their companies with a free of cost. Why? Because they would like to detect that is there any health issues is being there inside your body and you are not aware about it. Because so many people are there who are actually facing the cancer in their body, but they are not known it all. When the things go into the more advanced stage, then people are recognizing it. So now based on the symptoms is not going to make us understand. Like now, looks like bodies look everything okay. You don't hair, I mean, you will have good amount of hair. You looks like everything like a normal. But there are cancer cells are getting generated inside the body through any of the organs, from the head to foot, where people are not aware about it when it is got highly impacted. Until unless when it's got highly impacted, then only people are being realized. But after doing a lot, then we can't do anything. It's already damaged, already spread over the body. So here also, we are trying to develop a machine learning model to identify that a person is having cancer or not. And if you see, this is the variable class, which is our target variable. And what it contains, if you see, yeah, we have benign and malignant. So what are these two things means? These are the different kinds of tissues inside the patient's body. Tissues, the cells, its tissues, if I tested your tissues now, I have to detect that your cells are belongs to benign related or malignant related. If I found that if it is like a benign related, actually you are safe. If I found that, okay, your body cell contains malignant kind of tissues more, so you are suffering with cancer. That too you don't know about. Like that, we have some other information such as cells about the cell thickness, cell size and all. So here also I describe about this information in my notes. Just have a look here per minute. And if you see here, these are the every column informations. So cell thickness is about measures the thickness of the cell, how much thickness it contains inside the body. So it is ranged between 1 to 10. So if you have higher values, what? You have thicker clumps, which could be suggested as malignancy. If you have the lower value means what? You are not suffering. It has been, you are safe. Similarly, cell size reflects how uniform the sizes of the cells. So inside the body, if all the cells are in the similar sizes, no issues. But if I found something, a cell which is larger variations in size, so you can understand that you are suffering with again cancer. That means what? That cell is getting expanding a little bit more brighter, widely than other cells, which are actually cancer cells. Okay, and cell shapes, and mark adhesions. If you see how tightly the cells stick to each other, that means how each cell, like our atoms and protons, okay, and how tightly the cells are stick to each other, that is also matters. If the cells are not having such a tights, okay, so you can understand that it could be a malignant again. Like that, we have such a variables information about the, of course, we not belongs to the biological part of here because we don't have the enough knowledge. We don't have to be knowledge also, okay, to be frank, because machine will take care. Machine will understand the numbers, the patterns between the x variables and the y values, Yesterday I told you that which combinations of X variables make a person as detecting like a person is going to jump or not. So that jumping, the customer or predicting the customer like is going to have loan or approved the loan or rejected the loan. Some example I've taken yesterday. So what is happening between the X variables is about the patterns between the all the X columns, and we are going to take those, all these X variables as our inputs. We are going to take all these X variables as inputs. But this time, what machine learning that you are going to make? Logistic regression. Now let me take this data inside the machine, and I'll make you show what's going to be happening, to be frank. Okay. So going back to the Jupyter, yes, simply similar lines of code will be there. I'm not going to take just yesterday also I have taken a similar kind of pandas. So pandas is a library where this helps us to bring the dataset inside. So what is the dataset name? So breast cancer. So this is our breast cancer file, which is in this location, and I am saving those breast cancer.csv, and this is the location about it, and I'm saving it here. So I just replace the location to bring the dataset inside the machine. Let me run. We have to get the file. So we got an error. So I think I have to give 2 slashes here to get the data file inside. Yes. Now if you see, I successfully launched data, whole data inside the machine. Okay. The first column, which is unnamed, which is not a right column because it's just a serial number 0, 1, 2, 3, 5 patient numbers, which is not required. So what are important for us? Yes, cell thickness, cell size, cell shapes, all these are columns till mitosis. So what's the Y variable? Class variable. And what's your X variables? Remaining X variables. So yesterday we used what? A package, scikit-learn package. A scikit-learn package I used it. But the scikit-learn package will export the data always in the form of a numerical data. But what has happened to the class? Actually, it is text data. See? Benign, 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 malignant. So my scikit-learn package cannot take the data like a raw data in the form of text. So what should I do? I have to convert back into numerical. So for that purpose, I am adding an extra code here from scikit-learn dot preprocessing import. Okay, we have something called label encoder. So I'm calling it label encoder. And this label encoder, just like yesterday, will have a function and parenthesis. So I'm calling it as in short as LE. Now I'm running it. Okay, so LE is the function which is converts the data to text to numbers. So I am writing df.class. This is the problem that we have now, class variable. So under the class variable, I am asking to change. So LE fit underscore transform. So what it will do, it will take this data as input and you are asking to transform the data into numbers. How the data will be, text data will be gets numbers. So if you see, benign is there, malignant is there. Right? So alphabetically, benign will comes first or malignant will comes first? Benign will comes first, alphabetically. So all the benign data will be converted as zeros and all the malignant data will be converted as ones. Like this. So this is how it will be converted. So if I write down this line, fit transformation, and when I run it, and when you verify it once again, df.head, which will display 5 rows, and if you see, yes, my data class variable completely converted into numbers. So my data should not be in the form of any other format. It should be in the form of numerical format only. Then only I can process it. Then only I can fit the model. Now, once again, I am separating my, go back. What I done? Yes. In the last case, we have done like this. Similarly, I am doing the y variable. What is the y variable? Yes. Take the class variable and take your x variable. So df dot ilog. So what is this ilog is doing is, I want to take all these x variables in one group, one set of group. So without writing the variable names, I'm taking all together at one shot. So ilog will help us. So I'm telling that from the column 1 means what? Cell thickness. This is 0th column. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10th. So when I give 10th column and brackets close, it will take subsu only 9th column. If you see, cell thickness to mitosis columns only executed under the X. Neither you take an unnamed column, neither you take a class column into the X. Class column is there under the Y. So you splitted the data into two parts. To be frank, you splitted the data into two parts as X's and Y. Now what will be our next step? What will be our next step? Once again, fit the model. Right or not? And if you see, my linear regression, I have taken from scikit-learn package once again. But this time, it's not a linear regression. What do you have to do? Call the logistic regression. So I'm just removing I'm replacing the linear word with the logistic regression word. And this logistic regression will be replace the text here. So this time I'm calling it as log reg. You can give any name, but I just given the log reg name to understand easy for us. So this log reg is a function which will fits the model between x's and y values. So just like yesterday's case. So again, I'm taking up the logistic regression will be fitting the model between x's and y's. LR is not defined. Okay, I should change this LR. No? Sorry, log reg I have to write down, not LR. Yes. Now model being fitted. Now, like the way yesterday you have seen beta naught, beta 1, beta 2, yes, here also we are going to have, but it's not important to us now. But this time it will predict as what? Zeros and ones. So here, if you see, yeah, when you go back, you can predict the values. So if you see here, this is my data. And if you convert it at what? Zeros, ones. So this is what y values. Now, yesterday also, we predicted the values by passing the data. Here also, I need to predict the values. Like, if I send the data inside of all these combinations, will my machine will be detected as zeros or ones? If I send this whole data again from here to here, my machine will be detected as binary or malicious. I need to predict that. So what I am doing, I am sending all this data at a time. I am sending all this data at a time. So how you are going to send it inside? Yes, log reg dot predict is the function that we have, sending whole data x inside. So I am saving this one as y underscore predictions. Y underscore predictions. When I run it, it will predict for all the people from the data. And if you see, yes, you are successful in predicting the y values. So 0, 1, 0, 1. So actually, if you see, this is 0, this is 1, this is 0, this is 1. So the person is actually 0 means what? Benign, but model predicted as what? Malignant. Here also, person is benign, but model predicted as malignant because I have taken the random values. Now again, 0, 1, 3 zeros, 4 zeros, 6 zeros are there. This is 0, this is 1, and 6 zeros are there. That's correct. So some of the cases is been corrected, some of the cases are not correct now. If you see it is gone wrong. Even this case also gone wrong. So wrong means what? Model not predicted correctly. That means what? For the person who is having cancer, it is telling that not having the cancer. For the person who is having not having the cancer, it is telling that he is having the cancer. So these are what exactly mistakes. So to understand that mistakes, how well it is really predicting the right as right or wrong as wrong, it is going to verify with something called accuracy score. So there is something called accuracy score will be calculated. So what it is exactly does, if you see here, if I take this sample, simple example, this is y and this is y underscore predictions. Zeros means what? Benign. 1 means what? Malignant. So data is mismatching has taken a future trained mistake or returned to normal. Yeah, that's what I'm going to talk, Srinivas. You are right. Data is getting mismatching. That is what we have to verify, that how many mismatches is happened now. It is not predicting all the cases rightly. Okay, yeah, well catched. Now if you see here, we have 12 samples totally. Let's ignore the last 2 samples. Okay, so finally 10 samples, totally 10 samples. And out of 10, I'll write down like this. Look at this. We'll call it as something called confusion matrix. This will be interesting now. Listen carefully. This will be interesting. 0 means what? Benign. 1 means what? Malignant. Please share the PPT of logistic regression particular. Sure, Monica. At the end of the lecture, definitely I will share the notes. Even yesterday's notes also I will share. No issues. Okay. At the end of the session, I will make it sure to notes share this all things what we are learning. Okay, don't worry. And here, yes, I'm talking about the confusion matrix. So confusion matrix is what exactly? Actual data versus predicted data. So actual data contains what are the numbers? 0 1s. Predicted data contains what are the numbers? 0 1s. Understand this carefully, guys. It's very, very important actually to understand. Okay. 0 means what? Benign. And 0 means what? Benign in this case. So how many such samples we have? Both the cases as zeros. This is, imagine this is patientitis. How many cases we have such that 0 and 0 combination? That is what? Person is 0, model also predicted as zeros. And if you see, this is one combination, second combination, third combination, and fourth, fifth, sixth, seventh. I think 7 combinations we have. So out of full data, we got 7 combinations where we found that is what? Person is suffering with benign, and model also detected that yes, he is not suffering actually. Benign means safe issue, safe tissues. Okay. Person is having benign, model also detected as you have benign tissues. Then what is one? Malignant. So how many samples we have malignants? In this example, we have only 1. So that is what? This is 1. And if you see, then the question is, how many samples are mismatched samples? So that means what? Actually it is 1, but a machine predicted as zeros. And if you see, is there any cases 1 and 0 combinations? We don't have, but let's make it randomly. I'm making 1 and 0 for some reason. because I need to have some values here. So I'm making 1%. Similarly, how many people are there? 0, 1 combination. Yeah, 2 persons are there. 0, 2. Is it everyone is understood this? What's happened here? This is predicted values where machine is understood that does the person is what exactly he has. And this is what actual values where machine is understood that what exactly the same statement, what exactly the persons have. So now if you see these two people, these two combinations are actually safe. Like now machine is identified as yes, 6 people and 1 people, 7 people. So the person is having benign, machine also predicted as benign. The person is having malignant, machine also predicted as malignant. So these these two things are what exactly? Yes, sir. Compare between the actual and prediction. Yes, we are comparing it. Okay. And these two things are what exactly? Errors, mistakes, mismatches happen. So that means what? Machine is being failure in some areas. Like that, how many cases? Here 1 case, here 2 cases. So 3 cases have been mismatched. So that means what? If you see this one, actually 0, you predicted as 2. Sorry, you predicted as 1. So that means what? Actually the person is benign, but you predicted as malignant. This is one kind of error. So generally we'll call it as type 1 error, where the person is actually benign only is there, but you predicted as malignant. That means that actually is not having the cancer, but machine predicted that he is suffering the cancer. So that means what happens? People will be worried for some time. Oh my God, I gone for the hospital and laboratory tests are telling me that I have the cancer. So what happens? You will be worried about for 1 or 2 days, 5 days. So for second opinion, again we'll go for the another doctor. That's a other story again. So there is not much loss, to be frank. But what happens about the second case, where person is actually having the malignant? Person is actually having the malignant. Machine told that you doesn't have any malignant. Now what's going to be happen? So you got some symptoms. You go for the doctor. Doctor told that you are all right. Now what happens? You don't go for the second opinion now, because positive result that you are getting now, you feel I don't have any other things. These are just normal issues. But what is happening actually? You are avoiding that. You are avoiding that. You are having this cancer that you are did not detected. It's a mistake that has happened from the laboratory team, and you are keep continuing your life without using any other medicines. So the life is going to be more risk and danger or not. So which is type 2 error. So these two errors are quite common in respect to with any kind of field. Like a person is going to purchase the product, but my machine telling that he is not going to purchase. So what happened now? I'm ignoring to recommend the product. That is one kind of error. A person is not at all interested, but I'm still telling that, yeah, purchase this product, purchase this product, purchase this. Then what is the use? Actually, he's unemployed, and I'm asking to take the home loan. What is the use? Actually, he is unemployed, who is not ready to purchase anything. But I'm telling that, yeah, take the home loan for you, which is useful to you. And the person who is ready to take the home loan with all the with all the documents, he is ready with everything proper, but my machine telling that you are improper. So it is the loss to the banking sector or not. If I'm taking the cancer set, it is a big loss. Like life, loss for patient, life issues, life and death issues. When come to the banking sector, it is a big loss for the banking sector. Understood these cases, guys? The errors that is happens here. Like that, if you take several examples, whatever I told now, in these notes, there is that. Yes, it could be a manufacturing issues, automobiles issues, okay, an insurance person. Detecting that a person is a genuine or fraud. For example, a person who is genuine, I rejected his home loan, but a person is a fraud, and I am telling that he is genuine. What happens now? He will take the loan and he'll jump. He never come back to the bank. He never go back, and he's not going to pay back any amount against the loss. If it's a COVID cases, think widely. All people are experienced about the COVID. No need to tell. A person is suffering with COVID and mission predicted as not having the COVID. Then what happens? Now he thinks that it's a normal viral fever and he will go home. He spread his COVID to his family members first. And his family members and including him will go outside and he will make another people to get COVID. And this whole other people also will make another 100 people make COVID. So what is happening here? Whole nation is got spread about the COVID. Understand my point? Which is a very dangerous situation. If a person is not having the COVID, but model predicted as COVID, what happens? He will be strictly sitting in the room, no outgoing anywhere. Simply, he will take the medicines. Maybe it will becomes a little bit unnecessary expenses to the patient, or maybe some side effects also might happens. But usually, it is only one life risk. But previous cases what too many people's lives are under risk. So these things will be we have to identify that how many times it is being mismatched like that with the different examples. So in this case, if you say total people are how many? 8 plus 2, 10 people. So 7 people got predicted rightly now. So that means are 7 out of 10, which is 70% accuracy. 70% accuracy, it is predicted correctly. So out of 10, for 7 people, it is predicted as predicting as what? Benign as benign, malignant as malignant. Remaining 30% cases, it's not predicting correctly. Just taken random example, but we'll take up the same thing under the what do you say? This one, our spider, our Jupiter. So I'll take up this one, what we covered here to understand better. Okay. So insert. Okay. Anyway, some people are asking me to share this PPT, so I thought to put up those things in here also. Okay. So what accuracy level we consider data is correct either in linear or logistic regression? Good question, Srinivas. We always to have about 90% cases. Let me write the things. Yesterday in the linear regression also, there is something called R square will be there. I did not discuss it because of time limit. Okay, don't mind. And here we have something called accuracy score. This is for linear regression. And this is for logistic regression. So either of the case, any of the case, if you get greater than 90%, you can call it as excellent model. 100% getting is not an easy thing all the times. So I'm writing as greater than 90% will be excellent model. Greater than 80% can be varied as good model. Greater than 70% can be varied as what? Yeah, like an average model. So less than 70% if you see any times, you can consider what? Poor. So we never want to see going wrong predictions. We always want to see improvise the performance. Now let's verify for the cancer data set what amount of percentage of let's say accuracy that we made it. Okay, so I'm going back to the machine. So we predicted already, like the Excel data, we got the results. We are supposed to call the confusion matrix and we are supposed to calculate the accuracy scores. So how do we do this? So for the purpose, we have a direct code. We're not doing any lot of calculations. Everything has been there. We're just making use of it. Scikit learn, sklearn, learn dot metrics. So metrics is the library inside the scikit-learn package, and I'm calling confusion matrix first. And I'm asking to consider the confusion matrix between y comma y under properties predictions. And if you see, you saved what is your y and you said what is your y predictions. So we are asking to compare between them. So we're not doing any manual process. It will come directly results like this. See, and see the results. Yes. So 434. So if I take this example here once again. Okay, 434 here and 228 here and 10 and 11. This is 10, this is 11. Okay, when it comes to this case, what will be our accuracy? Sum of 434 comma 228 divides by sum of all these values, which gives us 96.95% of accuracy. 434 plus 228 divided by total number of samples. We will be having almost 683 samples there in this data. I remember that. Now, let us do the same operation under the Python. We are not going to do mathematics as told. Yes, from confusion matrix after that, call the accuracy score. Run it. Now calculate the accuracy score between y comma y underscore predictions and save it as AC accuracy score AS or else AC. I don't AC. AC and see the result. How much we got? Yes, same result 96.925. The value what I received under the Excel sheet. So 96% cases, 96.9. So almost 97%, right? 97% of cases, my model is predicting correctly as benign and malignant as malignant. So 3% of the cases, still it may go wrong predictions. Like it may predict as benign as malignant and malignant as benign also possible. 3% of cases. Is it all clear, everyone? Till now? Hope so. You are able to connect this logistic regression concept now. So domain could be anything. Like it could be e-commerce sector, telecom sector, healthcare sector, insurance sector, banking sector, financial sector. Okay, you irrespective of which sector you take, in all those places, definitely yes, our logistic regression will be most used algorithm in there. As I told, linear regression and logistic regression are the traditional basis method. From so long back, it is working out. So in the current scenario, where we are learning this artificial intelligence and other machine learning concepts, so other methods also working in the same passion in predicting the y values. We have something called, would say, k nearest neighborhood, support vector machine, noise based classifier, gradient descent algorithm, okay, and decision trees. Okay, so all these are methods are there. Working style will be same. What fit the model between x and y and predict the y values finally. Once we get the y values, we are going to cross check with the original y values and the model predicted values y values to see that how these values are predicted correctly, effectively in between the two things. So this is what going to be happening. Hope so. If possible, please sir, send this file also. Saurabh, yes, I will do it. I will do it now it only. All right. Because I'm going to take up another example. So let's not worry. I will do it now only for your request. So I'm giving them as logistic regression name I given for it. Yesterday as MLR. This is one case, this is another case. So I'll download these two things first and I'll keep it aside. I'm sorry, I did not download it. So I'm taking up these two things here in the detailed lecture. Okay, notes. I mean, code is there with you, and this will be. I will be pasting the notes as well. Give a minute. So this is how usually we will do the same thing in the classroom sessions as well. From the XLR, yeah, this is how we will create notes for them, people for helping them, because not everything is can't recollect all the things. Whenever you want, where's the lectures, you can't sit again 2 hours of story once again. So what we'll do, we'll give these notes for those people for the practices, so that whenever they look back the notes once again, they can recollect the knowledge of what they covered actually. So that's how we will do in our regular sessions as well. Okay. So I'll also share these materials with you into your folder only. Okay. At the end, I'm going to share this all this one at a time. Okay. So I'm giving the name as well, logistic regression. Yeah. So I'll give the name as logistic regression applications. Okay. And this is in this one I imported. I mean, I worked on both linear and logistic regression. So you just when you're revising it, you can understand it what I'm talking. So I'll give this MLR only. Okay. This is for SOS file. It contains logistic regression as well at the end of the notes, but yeah, but it contains MLR as well. Okay. And come back to the next one. Yes. So coming back to the learnings that what we have yesterday once again. What to do if there are multiple class labels? Yes, excellent question, MRP. Agreed. Now come back to the lecture. I'm going to take things. So, what I told yesterday, machine learning contains two subtopics: supervised learnings, unsupervised learnings. So when do we prefer supervised learnings? Because my client is giving me a task, a project to predict the target variable. Now I have taken a data set and identified that how does my target variable looks like. And what we understood that if the target variable is a numerical variable, I am choosing regression models. So what other models we have? There are so many models, such as I'll write down few names here: support vector machine. Okay, one of them, decision trees. And when it comes to when target variable as like a character, like today's benign malignant issues. So I will apply what? Logistic regression. Now you ask me, sir, when we have multi-classes, that is what? Multi-class. What does it mean by multi-class? More than two classes. Like yes or no is two classes. Pass or fail is two classes. Male, female is two classes. So when do we may have multi-classes? For example, I want to detect you as three different or four different categories. That is what where my target variable contains multi-classes. It may have three classes or four classes or five classes. For example, I want my machine trained. Okay. We want my machine trained. We want our machine trained to detect. I'm telling that to detect given image is belongs to given image is belongs to okay, and it is an elephant which is bigger in size, okay, or it is a crocodile. I'm making crocodile, or which is a water animal. Okay, most of the times it will have in the water, which is smaller in size compared with elephant. And another one is what? It's a monkey. Okay, and if you see, there are three categories, and all are not same. Agree? According to their size, according to their food habits, three things are different. Agree with me? I have taken one is completely, like a non-vegetarian, and elephant is a absolutely vegetarian, and monkey is most of the times it's vegetarian only, but people will treat this one also sometimes. Depends again. But the sizes, behaviors, okay, places where it will be stay is different. Monkey will be on trees, elephant will be on the land, crocodiles mostly on the water. Okay, and the common things are like all are contains four legs. These are the commonest common characteristics and differences. So what is happening here? Three classes. Like that, I can add fourth also. If you want me add, human also we can add. Human, right? Or man. How will you take man? Four classes. Now in that case, my logistic regression is not going to work. My logistic regression is not going to work. Here I can take such as KNN classifier, K nearest neighborhood classifier. Otherwise, support vector classifier. Okay, support under the support vector mission only we will have something called support vector classifier. Under the decision trees, so that is what decision trees will also works for regressions as well as classification. Few of the techniques will be works for both the cases. So under the decision trees we have again decision trees classifier, and another one noise base also there. Like that, several things are there, but I'm naming a few of the names here to make you realize. So these things are what works for classifications. Decision trees, support vector machines are such things works for both regressions as well as classifications. So, whichever the machine learning models I am mentioning over there, some of them works on the probability basis. Some of them works as with a linear algebra methods. Some of the methods will be works on the calculus based methods. The mathematics that we are learned in your 10th class, 11th class, from that basic inputs only, all the machine learning has working out with a different way of approach. That's why I told that minimum 10th class, 11th class is required to understand the data science. Later after, of course, your individual skills are also very, very important. How you are interestingly listening the session, how you are attending the classes, how you are practicing up. Again, these are things are very quite common for all the people. So, like that, in the machine learning itself, okay, so the most important models are almost some 12 to 15 are there, 12 to 15. I mentioned a few of them. Hope so, everyone is understood. Some of them are exclusively works for, like logistic regression exclusively works for 2 classes, but 3 classes, 5 classes means what? Some other algorithms. MRP, is it clear now? Hope so, I answered your question. Now, once you fitted the model to make more accurate, like to improve the best performance, there are several other concepts also there. Technically, we'll call as ensemble methods are there, which is called as bagging, random forest. Okay, where it will control the overfitting of the model's performance. So I'm not going to talk all those things, but I'm just giving an idea, basic idea. So what is going to be happen? For example, is this true for multi-class classification? Is this true for multi? Satish, is this true for multi-class? Which one you are asking for true? I did not get it. Is this true for multi-class classification means what? It's all applicable for multi-classes, whichever I mentioned here, apart from the logistic. Actually, logistic regression also can be done, but a lot of changes we have to work out. Like now, full-fledgedly, we have to doing the code work. Code work will be gets repeated with a lot of requirements. So again, task makes complex. So instead of fighting with only logistic regression, let's fight with these methods where easily we can get the results. That's what I suggest. Okay, understood? Okay, fine. Yeah. Now come back. So what I'm talking, yeah, there are some. So what is going to be happen actually? For example, I'm telling you one more example. I have to tell you this one also. Okay, okay. So the thing is, for example, a car model is newly innovated by the automobile technology industries. Okay, a new car model has been developed by the so and so engineers. So, do you think that the car after developed by those people will directly put down under the market? It will be displayed for all the people. Yeah, purchase it. We have prepared this car newly, very good, excellent. Just purchase it. Do you think that will they directly market in the market, or do you think that it has been tested for several times? What do you think? Definitely, the car should be tested before they launch in the market or not. Then only we can understand the issues, what's happening inside the car. If you remember, the people, if you have watched the movie Robo 1, okay, that Rajnikant's movie I'm talking about. At the beginning of the movie only, that doctor has been prepared that machine. Now his assistants will ask that, so will you give this direct to the Indian Army? No, the doctor will tell that, no, we have to test our model in the live performances. How does this robot will react with the real people? Will he able to take the right decisions on the right time or not? That is what he want to verify. Will the robot be able to take the right decisions on right time or not? He want to verify it. That's why what he will do, he will ask to drive the car for first time. So it will be gets confused between the sometimes because it has been trained with a rules and logics. So sometimes what happens when he will rotate his head, unknowingly he will hit the divider. So the person he break the rules immediately what is it crash with the he divide he make an accident. And second case, when he goes to the home, he will throw the TV on the floor. So this person, that means what the doctor gets realized that all these are practical issues making by this robot on the live environment. So whenever he is making the machines, whenever he making the mistakes, again he will bring back to the laboratory. Again he will train the things. Some more learning is required. Some more knowledge is to be inserted into the machine so that he can take the right decisions in a respective method. So similarly, okay, like as I told, car is really required to verify. That means what? He had to drive the car in the traffic. Okay, he have to drive the car in the traffic. He had to verify that is it taking the reverse gear properly or not, U-turn taking properly or not, left turn, right turn. Managing the task in the traffic is not really easy. But the functions that whether the mechanism of the car is really working well or not, he need to verify it. Similarly, here also our model is supposed to be verified before handling over to the client. Don't you think it is required? When you prepare something like a food only we have prepared, a visitors are okay. Directly you will take the food in front of them or you test it first. If it is found odd now, you don't give it properly. You will realize if the salt is less or the sugar is less, immediately you will make it mix those things and you will take the visitors. That or not. Similarly, our model is supposed to be tested before. So what we will do in that case, we will divide the data into two parts. That means what? Data has to be partitioned before fitting the model. Before fitting the model. So where data, let's say imagine example. We have 1000 samples with the 10 columns. So data will be divided as two parts. Let's say this 1000 samples have been divided as 70-30 ratio. So that means what? 700 samples with 10 columns as one group, 300 samples with 10 columns as another group. So this one I will call it as training data, and this one I will call it as test data. So once I will take up the only training data and I will fit the model. And after that, predicts the model. Then you need an accuracy. So that is what? Training accuracy. Similarly, on the test data also, we don't fit the model, but we will predict the data based on the training model. So at the end, you are also going to have test accuracy. If I found that training accuracy coming as 90% and test accuracy also getting as okay 88%, so model is good, model is excellent or good, whatever you take, because 90, 88 both are coming same. So problem comes in what case? When the both numbers are not same. When the both numbers are not same. Like here I got as 90, but when it comes to the test data, okay, I got as 60 only. There is a high difference between the training accuracy, test accuracy. That is what my model, I told that car is going to give the best mileage. Minimum 30 kilometers it will give. This is I told. Okay. Car is going to give the best mileage outside with 30 kilometers, 30. But after launching the car in the real time, when the user is using it, it is just giving 13, 13. I promised it as 30, 30, but actually it is giving 13, 13. So how much of difference? 50% of the variation is there. 30 is, you said 13 is been happened. So there is a lot of mistakes could be happened in developing the model or not. You did not verify it properly in the test phase. So we have, so that is what model has been, what happened here actually, to be frank, we'll call it as overfitting. Model has been having facing with the model overfitting issues. Can you differentiate between training accuracy and test? Training accuracy and training accuracy? Differentials, so this differentials means what? For example, here I am fitting the model, but I am missing the step here. Look out here. I am missing the step of fitting the model. Why? Because same model I am going to make, I'm going to make use here. Same model I am going to make use here. Shall I show the code? Otherwise, shall I do the code for this example? You want me to do? Okay, yeah, let's do it then. So a friend is asking to make it done. Then, so I'm going back. Okay, so I'm going back. So what I'll do, I will keep this exercise as it is. So I'm keeping this exercise as it is, and I'm going to create a new file. Okay, so that I don't want to disturb the previous file. It can be take as a reference. Feedback link. I think Chandana will take care about it. So I'm doing my exercise. So I'm taking my file as it is. Okay, I'm following the data once again. And yes, label encoding work will be done here. And yeah, transforming the data, that is also done. These are things common. Okay, and here XY separations, this is also common. And yeah, logistic regression, calling the logistic regression function, this is also common. But I did not fit the model, I just call the logistic regression. But before that, what I'm doing, I have to divide the data into two parts. I have to divide the data into two parts. So how do I do this? From scikit-learn dot, okay, train underscore, sorry, not train, model underscore selection. From the scikit-learn only, if you observe that everything I am taking out. Yesterday I called linear regression. Today I call logistic regression. Now model selection I am calling. Matrix also I am calling. Okay, such an important library it is. And import train underscore test underscore split. Yeah, Nidhi, I'll come back to the point. Okay, just give me a minute. Let me finish up this discussion. I'll come back to the point of validation and test data. Okay, there is some slight difference. So train test split. Okay, I'm taking our x comma y as inputs, and this will divide the four folders. One is x train, x test, y train, y test. So if you go back, what I said, it is been divided into four parts now. Training data, test data. Okay, and if you split as x and y variables separately, from training data you will have x and y. From test data also you are going to have x and y. So I think some people are maybe going to log out. What I guess. Chandana, are you there? I think she is not there. Just give me a minute. Just give me a minute. I'm dropping a message to them. Okay. Okay, I drop it. They will look upon these things. Okay. Now we'll cancel on the code part. What I'm talking. Normally, 4:30 time is time for feedback, sir. I'm not sure about that timings issues, Satish. Actually, I mean, 5 till 5 p.m. I have to take the session. There is only one thing I have known about it. I'm not aware about the feedbacks. Okay. Yeah. So anyway, I informed those people. They will get back on this. Okay. Don't worry. Actually, my question is, if you want to know the accuracy, you have to test with some test data. Yes, MRP, you are right. Okay. We have to test the model with some test data, then only we'll come to know. Otherwise, how can you give the assurance without testing it? So now currently imagine I don't have the test data with me. So what I'm doing, I'm splitting my data into two parts: training data, test data. That is what happening here now. Okay. Now let me show the code part. So I am then why there are training accuracy and test accuracy? Your test, see, so maybe if your previous question is for just one person to test it, I'm not going to test with only one sample of test. Now I want to test with many samples. I want to test with many samples. That's why I'm looking for the test accuracy results. You see, if you see what happens here, I am sharing my data into two parts, such as tested data set should contain 30% of ratio. Training data set I am giving by default it will take us 70%. Okay. So I'm dividing the model, I divided the data into two parts. It's been divided as X train, X test, Y train, Y test. So totally four data files have been split out from the overall data. X train, X test, Y train, Y test. So X train, Y train will contains what? 70% of the data, and X test, Y test contains 30% of the data. Now here, I have to fit the model. But the fitting the model, when I'm fitting the model, look out here, this is what we have to observe. I am using X underscore training and Y underscore training. So fitting the model with only X train, Y train is happening, not with the whole data. But when it comes to the predictions, this is the predictions lines now. Look out here. So I'm sending only training samples. So I will call it as this is Y predictions of only training. Now this time I'm going to see predictions even on the test sample, which is, observe that test data set is not part of the fitting the model. When I'm training it, I did not send the test samples. But I'm testing on the test samples also, which is not part of the model fitting. This is what you're supposed to understand, which is not part of the model fitting. So that means what? My test samples is in an unknown samples, which my machine is never seen it. Okay, my test samples is an unknown samples where my machine is never seen it. When it is seen, when you fit the model here under the line number 7, you made our machine to see only training samples, but you did not send the test samples. But you are predicting on the test samples as well. It's predicted. Now it's time for to calculate accuracies. So again, so accuracy I'm writing as training underscore accuracies. Okay, and this is test accuracies. And this is Y predictions testing, and this is Y predictions training, and this is Y underscore training, and this is Y underscore testing. Let us see the results. And if you see what amount the values will get, accuracy score, I have to call it because I have taken a separate file now. Yes, I have to write down the line first to call the accuracy score. 1 second. We got an error here. So we can ignore the confusion matrix now. Yes. Okay, it's printing only one test accuracy. Just a minute. Otherwise, I'll take this one here. This is training accuracy and this is test accuracy. See the results. What has happened? Training accuracy I got as 96.66 and test accuracy I got as 98.04. So almost results are good. Almost results are good in this case. Now I'll come back to the Nidhi's question. What she was actually asking, sir, we have something called validation data. What does that is mean? I'll tell you now. Okay, I'll tell you now. Now this is what the results that we got it now. 96 now. Let me write these things. 96 here and a 98 here. This is what the results in this case. But imagine in some other example, I did not got the same results. I got as 90 here and 60 here. That means what? There is a high difference. So our model is actually facing a issues called overfitting. Yeah, I informed Hardik. I informed those people. I don't know whether these people are not responding. So they will log in 2 minutes. Please stay back. Okay. Yeah. Come to the point. What I'm talking is, yeah, when we see the difference between 90 and 60 is highly difference is there, we have facing a overfitting issues. Now, how to control the overfitting issues? There are some methods there, such as we have something called regularization is a techniques are there. Regularization techniques. And after that, we have something called ensemble methods also there. So these techniques will help us to control the overfitting. So when I'm control the overfitting, so what happens? Again, I'm going to verify. So this time what I'll do, I will divide the data into 2 parts. Okay. So this time I'll make it as 150 samples only. This time I'll make it as 150. That is one time I'll call it as test data, one time I'll call it as validation data. Actually, both are works in the same direction. The thing is, when I predicted the samples, okay, so this time I got 60. Okay, this is what I got 60. But what I've done, I control the overfitting. Once again, I tested with a different set of samples, which is another 150. So this time it may improve, let's say 80. So that means what? To be frank, our test data only is been divided at 2 parts. One is for validate our model once again. And finally, after changing the things like applying ensemble or regularization methods, after changing few more things, again you are retesting your model with another 150 samples. Now this time you may see better performance than your previous. I think you people have got your attendance form. Now we can make use of it. Okay, now come back. Is this concept is clear what I told? We have less time. I understand that you may be still, you have some questions running in your mind, but try to connect what I'm talking. Try to connect what I'm talking. So like that, yeah, if you face any challenges called as overfitting, Now we are supposed to make use of ensemble methods. What this exactly it will do? Reduces the, yeah, I'll tell you. Ensemble methods means what exactly will do. Okay. Here. Identifies unnecessary variables in a short line word. Okay. Identifies unnecessary variables and removes those from model fitting. So when the model is going to be overfitted, when we have too many x variables. So our methods will help us to identify the unnecessary variables. Variables means what? Columns. And removes those from the model fitting, such that performance of the test accuracy will get improved. Performance of the test accuracy will get improved. So this model validation, data partition is quite common. I'm telling again, this model validation. Model validation is what? Calculate the test accuracies, nothing but. Data partition is what? Splitting into two parts. So data partition and data model validation is quite common for all the supervised learning methods. Remember this. Irrespective of which one you are using doesn't matter. For which dataset you are using doesn't matter. So you are supposed to apply data partition and data validation for all the models whenever you are using. Which is first validation or test. So it's about the namings actually, MRP. Okay, it is not about the which one, because when you are dividing the data into two parts, now both are going to be same. Like if you see what I told, we divide the data as 150 here, 150 here. So there is no difference in between the samples. So you are considering this one as test data, you are considering this one as validation data, doesn't matter. Finally, we have to improve the performance after doing like now 1 or 2 trials. Simply if I tell the first time trial with the test data failed, again I verified it. Again I verified with another set of data. Second time trial. Simply words now if you ask me simply now, this is test data 1, this is test data 2. In simple words. Okay? In simple words, this is test data 1, test data. But people are giving it different namings. Sometimes it's called as validation data, sometimes it's called as test data. Both actually works like the same direction. Yes. Anyone has any questions for the logistic regression so that I can make it clear in this point? Thank you, Pradnya. So I would like to give, so maybe tomorrow, yeah, one more point. Tomorrow will be, we won't have any session, okay? Which is 15th August, you are aware it. And our session will be on again Friday, that is on 16th.
Yes, sir, you are correct. Tomorrow we have holiday.
Yeah, it's an official holiday for all the people. So we don't want to disturb your holiday, public holiday. So we would like to continue our things. Like if you want to practice of these things, you can practice it. That's up to you, okay? Anyway, I'm going to share these things with you. And Friday will be again, as usual, we will be session. So let me, because we have some more time left, so I would like to give about small introduction about the now unsupervised learning. Let's not waste the time. We have some more time left here. So I'm going back to the part of unsupervised learning. Okay. Can we ignore validation set in our research model and take only test data and training data? Yeah, if results are accurate, then no need to go on the validation set again. If your results are good, then no need to go for the validation. If the results are not good, then we have to think of that. Let's take up some more sample and make it as validation set. Like as I told now, overfitting kind of issues if it happens. In that case, we have to verify about it. Otherwise, we can ignore it if the results are good. Okay. Yeah. Now the thing is, what topics will come under unsupervised learning? Unsupervised learning means what? We are not targeting anything here. We are not predicting anything, to be frank. We are doing a different kind of analysis, a different setup of analysis, such as first one is principal component analysis. Okay, and second one is cluster analysis. Thank you, MRP. And third one is, yes, we have a few more topics. Let me write it down. Association rules. Association rules is also called as market basket analysis. You might be hearing about this word, I don't know. Okay, and fourth one, recommendation system. The place is not sufficient here where I'm writing, but just understand the things. Okay, recommendation system. So I'll try to give the inputs of all these four analysis. What are all these actually uses? Okay, some inputs I'll try to give so that you will have an idea about it. So in the next session, we'll see what else we can do with the topics. Okay, based on the other 2 days that we have planned. So I have to cover up a few more learnings for you. Actually, what I planned. I want to cover up NLP. I want to cover up a deep learning part also, but time will be not sufficient, I guess, for all the things. But I'll give some inputs from the unsupervised learning today only, at least. Okay, I'll come up with a proper plan for Friday and Monday as well. Okay, yeah. Now come to the point of principal component analysis. What is exactly it is used? When do we use? First of all, we have to understand when to we use. When to use. Yeah. So in the MLR example or logistic regression example, if you see, our X variables are like now between 5 to 10 variables only. Between 5 to 10 variables. So what happens? Easily we can recognize that what variables to be useful for model development, what variables are really not useful for model development. So if I take a data set where it contains, okay, such as hundreds of variables, because in the real-time environment, if you go and sit somewhere in the different set of domain, you may across hundreds of variables with there. 300, 500, 1000, 2000 also possible. So now identifying the best suitable variables is really impossible. Best suitable variables is really highly impossible to us. Now what shall I do then? Now I'm going to use this technique called PCA. What does this do? It will reduce the dimensions. That is one case. Dimensions means what? Columns, okay? And next one, it will transforms the data, whole data, transforms the whole data and put into a compressed format within the minimum number of variables. So what does it mean? For example, you people know when we have too many files in the computer, we will zip it. Right or not? If it's a 5 GB of files, if you make it zip it now, so it will compress it with just 50 MB or 30 MB will be there, or 1 GB. So that means what? 90% of the space will get controlled when you made your files zipped. Similarly, our PCA also will compress the whole data into with a minimum number of variables. For example, if I tell that 100 variables information is enough, it will reduce to, example I'm telling, okay? It is reduced to just 5 to 8 variables only. Such a powerful technique it is. So that means what? The maximum information will be saved within the 5 to 8 variables. It's not a perfect range also. If I choose another data set, you may get 4 variables only as best. If I take up another data set, you may take 10 variables as best. So it is not a perfect range. I'm example I'm telling. It's an example, just an example. So once I successfully reduces the dimensions of the whole data into 5 to 8 variables. Now what I'm going to do is, we will make use of only this 5 to 8 principal components. We call it as what? Principal components only for model fitting. So it's just a dimensional reduction techniques. It's just a dimensional reduction technique in reducing the higher dimension to lower dimension. So again, there is some mathematics involved in the backend. There is something called eigenvectors, eigenvalues are there. So using that logic, it will control the higher dimension to lower dimension. That is the purpose of learning this one. Okay. Now I give you the next one. Then what is cluster analysis? So I will do one thing. Cluster analysis, I will take up this one into the next because this is an important thing. So I will talk about the association rules and recommendation. So what is exactly this will do? What is exactly this will do? Association rules and recommendation system. So you could have observed that when we are watching a YouTube video of different content. So what kind of contents will be there on the YouTube video? It could be cooking. It could be movie. It could be fun. Right or not? It could be fun related. Okay. It could be science related. It could be politics related. Right or not? It could be, what else we can talk? News related. Okay. It could be movies like horror or action, family. Like that, if you take, there are several contents are there. So when you start watching one or two videos regarding it, it will try to push up those videos in front of us. Okay, imagine a person A, he is interested in movie related and let's say cooking related videos. Person B is also interested in such as movie related videos, okay, and he's also interested the fun related videos. Now what is the commonality between these two people? The common interests are what exactly? Movies, right or not? And if you see, movies the common part here between these two people. Now what is our association rules or recommendations we will do is, okay, we will try to recommend because these two people are having the similar natures. Okay, so why can't, for the person A, why can't we recommend, what is that? Fun movies, fun videos related. For the recommendation for the person B, okay, what I'll do, I will try to recommend the cooking related videos. So this is what happens. All of you understanding this part was what I'm talking? So how I can recommend to a person in the YouTube, or it could be Netflix, Amazon Prime. If people are using Amazon Prime, or it could be AHA or Disney. So when you open that app, you could see recommendations will come automatically. How that recommendation is getting applied? Because based on your similarities, based on your similar past watched history, accordingly, what other movies you might like it, my mission is trying to recommend those things. So these association rules and recommendation systems are actually working in that concept. Now you can imagine how many things are there daily happening that we are around with us. Okay, in the Instagram also, okay, we people are adding so many people. We will follow and some people will follow us. So that is what a friend is going to be our friend again. So it is recommending us, suggesting us. That is also one of the example in the reality which is working. When you open these e-commerce websites, Amazon website, okay. So for example, you are an individual user, I'm an individual user. But when you open it with your login account and when I'm opening with my login account, your products and my products is not going to be same. Agree with me or not? Your products is different, my products are different. That means what? My interest, according to my interest, Amazon is recommending what products is really going to be purchased by this person. He will display those brands in front of you. According to your interest, he will try to push up those products in front of you. Like us, okay, there are several people are there who are watching the similar kind of products, and we are calculating those ratios of how much time that you are spending in observing about the product, okay, and how many times you clicked on the product, okay, and how much time that you spent, okay, how much times you clicked and you purchased or not, or you added into the cart. So all these calculations are working in the backend. All these calculations are working in the backend and it is storing under the machine learning. So our association rules and recommendation system are actually working on those concepts. Hope you are understanding what I'm saying. So all these are real-time and practical examples daily that we are observing. Daily, at least one time or two times, we will watch YouTube and Instagram. Have you ever thought that how does the recommendation is how that videos are coming in front of us? Why not the same videos is not coming to our friend account? Why he is getting some other different videos? Why I'm getting a different thing? Because according to the past behavior, what kind of videos that we are seeing, accordingly it is trying to recommend. So it's not observed by any person. And machine is getting keeps changing the recommendation to the all the users then and there, then and there, then and there. After just a few 15-20 minutes, immediately our YouTube page again will be displayed with a different set of videos, not comes back with the same videos. Recommendation automatically changes for every few minutes. If we don't observe these things, please observe this. At least today, you'll get to know what I'm talking. At least you will understand what I'm talking. Is it all clear, guys? What I'm talking? So that's all. I think I don't want you people to be bored out of too much, but I want to make you understand the realities which is happening around us. Lot of changes are happening through the technology wise. Applications are already applied. Only the thing is what we are making use of the applications every day, but we don't know how those are working. And machine learning and our AI or deep learning, all these are part of those changes which is we are seeing every day and we are adapting it. And I want everyone to be learn these all concepts and get into the right field based on our interest. Why for the same person recommendations changes? Yes, because for example, my mission has been understood that I recommended some videos for you, but you are not watching it. That is what I am failure in understanding your requirements. Agree? I opened it, you just watch it for some time, I stop it. So after 10 minutes, what happens? My mission is understand that my videos is not useful to you. I say I am the person to make more money. I'm there. I'm the YouTuber. Okay. I want the person to be like not. I want to revenue my money. So if I'm recommending a wrong product to you, how can I make you attract? Like I'm asked, see, you are a male person. So to be frank, okay, you are a male person. I'm recommending a wrong product to you. Like purchase the handbag, purchase the handbag. Then what is the use? When you're ignoring means what I should realize, okay, this person could be male. He's not interested in the bangles. He's not interested in the handbags. He's not interested in the clips. Okay, I have to recommend something else for male users. Let's say, yeah, let's recommend the belt. Let's recommend the purse. Let's recommend the t-shirts and jeans for the males, which is suitable to him. When I push the right recommendations, then only you will be keeps watching, then only you will keeps purchasing, then only will keeps ordering, then only my business will run. So this is what happens. Is it really possible to monitor millions of people watching YouTube content and do the kind of recording? Actually, your question is right. That's what. No person is sitting in the back end and watching our recordings. Everything is part of machine trained. Everything is part of machine learned. Machine is been observing. Machine is taking the recommendations. Machine is suggesting the things. Machine is taking back the videos. Machine is pushing the videos. No person is sitting in the back end. Everything is machine doing its own behavior. Of course, yes, this will require huge computing power. Definitely. Definitely. It's not a small thing. Every day, Instagram, how many people are logging it? Every day, e-commerce website, how many people are logging it? Every day, Google Pay, Phone Pay, how many people are logging it? It's not a simple task. Na? Within a few minutes, how many people are making Google Pay at this moment? Just imagine. The server should be maintained the compilations done at a time that you are asking to send 10 rupees. You are asking to send 1000 rupees. Like that, lakhs of people are doing it 1 minute. You just imagine the things. It is pressing like on the. Sometimes you could have heard about this news. So people are falling on the Book My Show to purchase the movie tickets, and Book My Show has been server down. This kind of issues you might be seeing. Like there's so many things are there. If all the people are at a time falling on it, so obviously it will happen. Right now, guys, everyone is clear what I'm talking? Yeah, I think it's a time for to give the notes. I forgot again after that. So let me put down those things for you people who are asking to share my notes. So yeah, let me take this first. Otherwise, I'll keep forgetting. So MLR, yeah. So I'm uploading here only. Okay. So data file upload, logistic regression applications, code, okay, MLR code, MLR notes. One by one, I'm uploading it all. So notes is there, two types of code file is there, MLR PDF is also there. Yeah, yesterday's data file also I'll upload it, that advertisement file. I'll go there. Yes, yesterday's file also been uploaded. If anything is missed out, or if you want me to anything to share few more learnings, or if you want me to share any of the textbooks also, I will do it, no issues. At the end of the lectures, I will give up some more materials for you for your learnings from your end. Okay. Yes. Any more questions from anyone? Do anyone has any questions? Sir, better I think I have to check with the XLR team whether I can do that things or not. Like sharing the drive link can be accessible or not. I have to verify it. If they are agreed with me, I'll put up all those things in one drive link and I will share this drive link at the end of the sessions. Okay. I have to get the permission from the XLR team regarding it. That's why I'm uploading in the chat box itself so that you can have the advantage then and there. If possible, I will upload it. Not a big deal, Srinivas. Okay. Yes. Any other questions? Anyone has anything?
Hello, Advait. I hope you're done.
Yeah. So just give me a minute, Chandra. I'll just close the things. I'm just looking for. I'm just
Sure,
reading up the
sure.
comments one by one. If there is anything else missing out. Okay.
Yeah, sure, you can take it.
So there is Nandini. You asked something question. I am Nandini from JSS and SSU Mysore. I need to know. Can you organize the offline session for our PG students? I think Nandini, you can just be in touch with our XLR team. So definitely they will help you in this regarding that you are asking for some offline sessions. Na? You can definitely ask for the XLR team. They will get back to you on this. Okay. I think I guess I have answered all the questions. I'm looking again for all the chat box. Is there anything I have missed out? Any question from your chat box? I think it looks like I answered all the people. Okay. Possible load that document into the XLR LMS portal. Uh, I have to check with XLR team regarding it, Selva. I'll verify this point. Okay. One thing is a drive link you're asking me on LMS portal. So I'll verify with these things our XLR team and I'll get back to you on this. Okay. Monica, I already shared the group notes on the chat box. Did you not receive or what? Can you post once again? Yeah.
No problem, Advait. I will upload in the LMS. Okay.
I think yes, people are here to take care of these things. So don't worry, you will get all the things what we're discussing here. Okay. So Nidhi is telling for my research model, shall I make only one CSV as split in training and testing, or shall I make different CSV for training and testing separately? I have 50,000 5 lakhs plus extra stress. So I think we have to make two parts because 5 lakhs of data may be not work directly into your machine. Maybe again your system also should be support for you, Nidhi. So we are better you don't take total data at one time. Take some part of data because maybe your system will gets hanged out if you have large amount of data at a time. So I suggest to take only 1 lakh of samples for the initial development. Okay. Then after that you can go for the like testing and all. So I mean, like if you do it with similar small amount of data, your model gets ready. Based on running time, how much time it taking by your mission, then you can take the some more samples if required. Okay. I hope I have answered very quickly, but yeah. And sir, CNN will be discussed in the last session, Tarimala Devi. Okay. So during the deep learning lectures, I will tell you. Maybe on Monday's discussions. So next Friday, I mean this Friday, tomorrow, day after tomorrow. So I'm willing to take up the cluster analysis and the NLP classes. And the deep learning sessions will be done on Monday's lecture. All right, Tamila. So this is how I plan because I'm trying to cover up all the things what I can do. Monica, WhatsApp group maybe not possible in this case because XLR won't allow these things. So you can be in touch with me with the XLR, or you can raise your feedback, your interest in the feedback form, so that XLR people will be try to answer that part. Okay. Is it possible to train a model at different stages? Yes, it's possible. It is possible. Okay, Murphy. Thank you so much, sir. Good and interesting lecture. Fine. Yep. Any more questions, guys? So I think the time is up. So all right. So we'll keep in touch in the next session again. I mean on Friday, tomorrow, Thursday. So which is all day. So keep in touch again in the next session. Okay, guys. So
Yeah.
thank you all.
Thank you, Advait. So, dear faculty members, I'm sharing the attendance link. Please mark your attendance. Okay. If any more questions, you can ask me. And those materials I will upload in the LMS. Okay. By today evening or else tomorrow morning. Okay. And tomorrow we don't have a session. Again, we have a session on Friday. Sorry, we can't able to provide day 1 and day 2 attendance links. Okay. I hope no more questions. Yeah, I didn't see any questions here in YouTube and Zoom as well. Marking attendance in LMS can be taken for certificate. Yes, of course, you can do that. Yeah. Happy Independence to all. Day to all. Yes, Padmaja. I will upload day 1 to till day 5 materials in LMS. Don't worry about that. Okay, fine. Yes, I'm done with your questions. We'll wind it up. Good to go. Advance happy Independence Day, everyone. Take care. Yeah, bye bye.